In today's video, we're going to be multiplying and dividing numbers in scientific notation in regards to looking at them within word problems. So we're going to be given a certain word problem, determine whether we multiply or divide, and then use the laws of exponents and rules when we multiply and divide scientific notation. And in this problem, we have how many times greater is this number, then this number, and express your answer using either standard notation or scientific notation. All right, so this one is telling us you could give either answer. Sometimes they specify, but this one we can give either way. I'm going to show you both ways. So first, I notice whenever I see how many times greater, I see this wording right here that tells me I have to divide. Okay. So when I divide, I'm going to make a fraction. 1.943 times 10 to the 8th divided by 2.9 times 10 to the 6th. And I use my rules of division. So I divide these numbers out in front here. Now I need the calculator. 1.943 divided by 2.9, and you get 0.67. And then when I divide the powers of 10, you keep the base and subtract the exponents. So it's 10 to the 8 minus 6, which is 10 to the second. Now, this number right here is neither in standard notation nor scientific notation, right? Remember, we want one non-zero digit before the decimal. So if I want that, I have to move this over, right? So when I move this over, you're making this number bigger. You're making this into 6.7. And you can't just do that. You have to adjust the exponent as well. So if you're making this bigger by 1, this gets smaller by 1. So it's times 10 to the first. And this would be my answer in scientific notation. Now, if I wanted it in standard notation, I would have to move the decimal over again since the positive 1 makes this bigger by 1. So that would equal 67 times greater. And that would be my answer in standard notation. Okay, so they could ask either way, scientific notation or standard notation. Let's take a look at another problem. Okay, the size of a cell is typically found by capturing an image under a microscope, then using software to measure its diameter. The two cells are measured using this method. Boom, boom. How many times larger is the diameter of cell G than the diameter of cell H? This time they wanted standard notation and rounding it to the nearest tenth. Okay, so we're going to put in standard and round it. All right, so now again, how many times larger? How many times larger? That means I divide these numbers out in front. 3.84 divided by 4.4 is 0.872727. That's why they round it. Okay, dot, dot, dot. 10 to the negative second and 10 to the negative fourth is 10 to the negative 2 minus negative 4, which is the same thing as adding 4. So this would be times 10 to the positive second. Now, this number is not in scientific notation, is not in standard notation. If I want to put it in standard notation, I have to move my decimal over 2 spots to the right. So if I move this over 2 spots to here, right, then my answer would be 87.2727 ... But still, I'm not at my answer because I have to round it to the nearest tenth. the 10th spot. The 2 is in the 10th spot right here. So that's in the tenths. Remember, when we round, it goes tenths, hundredths, thousandths, 10,000ths, all that good jazz. Okay. But I want to round to this spot. So if I'm rounding to this spot, I have to look at the number afterwards, the 7, and I have to determine whether I bump it up or keep it the same. So the 7 bumps this up to 87.3. And the reason why I did the squiggle equal lines is because that means it's not equal to, it means it's about, right? Whenever you round, it's going to be approximate. So that's why I use the squiggle equal lines. So 87.3 is my standard notation answer rounded to the nearest tenth. Okay. All right. So be careful with how they ask you, whether you want a standard notation or scientific. All right. Let's take a look at another one. Here we go. 5.7 times 10 to the 6 bacteria are measured to be in a dirt sample that weighs 1 gram. Use scientific notation to express the number of bacteria that would be done in a sample of 21 grams. So if this is the bacteria in 1 gram, to figure out how much is in 21 grams, this is when we multiply, you guessed it, 21 times 5.7 times 10 to the 6th. So again, we multiply these numbers out in front, right? There's no powers of 10. So if this is we want to figure out the amount in 21 grams, we have to multiply it by the amount in 1 gram. So we multiply these, right? 21 times 5.7. And we get 119.7. And then I bring down the times 10 to the 6th power. Now, I want this in standard notation or scientific? Okay, I want a scientific notation. So if I want a scientific notation, I have to have only 1 digit before the decimal. So I have to move this over 2 spots. Boom. Here, and I'm making this number smaller. So when I make that number smaller, this number has to get bigger. By how many spots did I move? I moved it over twice, so it has to get bigger by 2. So 6 plus 2 is 8. And here would be my answer in scientific notation. Okay. If it was in standard notation, I would just have to move the decimal spot over 8 spots. But that's a lot of numbers you're typing in. All right. So I think that's why they asked for it in scientific notation. Okay. So again, how many times greater? That means you divide. All right. And also could be a multiply problem like this. And you just multiply the numbers out in front, keep the powers of 10, and add the exponents. Make sure you specify, or if it's specified, whether you put your answer in scientific notation or standard notation. That's it for today's video. Thank you for watching, and always remember, whether you're solving for X or Y, always give math a try.